Can this glucose monitor actually pass an FDA-style accuracy check? If you are asking whether your glucose monitor is accurate enough to trust, this report gives a stronger answer than a simple average. The on-screen data in this walkthrough comes from the sample or mock data set included with the app by Werner Tools and Chris Werner, so this is a demonstration of the workflow rather than a claim about your own device. In that sample file, the app found 8 eligible same-day lab dates, and the SMBG snapshot line shows 100% of those dates within plus or minus 15% and 100% within plus or minus 20%. That is the good headline. But the app also warns that this is an FDA-style snapshot rule, not a formal FDA clearance study. What data the app needs before it can judge accuracy? To get that snapshot, the app needs matched data. First, you enter your glucose readings, and the widget allows 1 or 2 same-day glucose values. Second, you enter dated lab results, including lab fasting glucose. The accuracy check only uses dates where a lab fasting glucose exists and where the same lab date also has at least 2 glucose readings. That requirement matters because the app is trying to judge consistency on the actual lab date, not across nearby days. Read the file-wide monitor accuracy summary first. The first place to read is the monitor accuracy summary in the report. In this sample file, the overall line reads estimated A1C minus 6.8%, fair, average glucose minus 9.4%, fair, and direct glucose plus 0.4%, very close. The most important of those three for the meter itself is the direct glucose line, because that is the same-day reading compared directly against lab fasting glucose. A variation of plus 0.4% is extremely tight alignment in this dataset. Open the detailed report and audit one lab date at a time. The detailed report viewer lets you audit that summary one lab date at a time. Each lab row shows the lab fasting glucose, the matched glucose reading, the percent variation, and an agreement label such as very close or fair. For example, one lab date shows 134.7 mg per deciliter in the lab and a matched glucose reading of 131.7, which the app labels minus 2.2%, very close agreement. Another date shows 111.2 in the lab and 114 in the reading, plus 2.5%, again very close. That is how you verify the summary is earned, not guessed. Does the sample file meet the app's FDA-style SMBG limits? For the SMBG setting, the code inside the widget states the FDA over-the-counter style targets as 95% within plus or minus 15% and 99% within plus or minus 20% versus the lab comparator. In the screenshot here, the app reports 8 eligible same-day lab dates and shows the SMBG snapshot meeting the rule at 100%, 8 out of 8, for both bands. So within this app's built-in snapshot logic, the sample monitor is inside the SMBG limits. Why SMBG, BGMS, CGM, and ICGM are not judged the same way? The same screen also explains why monitor type matters. SMBG and BGMS use different thresholds, with BGMS being tighter. CGM and integrated CGM are handled more cautiously. The code says the app shows an agreement snapshot against available same-day lab pairs, but it does not perform a formal CGM or ICGM accuracy assessment because ad hoc home readings and missing study controls are not enough. So a good-looking chart does not automatically mean a continuous monitor satisfies its regulatory standard. Can smartwatches or rings be verified as FDA compliant here? The answer is even stricter for smartwatches and rings. The code explicitly says that for a watch or ring claiming to measure glucose on its own, the app reports only an agreement snapshot, not compliance. It also states that the FDA warned on February 21, 2024 that it had not authorized, cleared, or approved any standalone smartwatch or smart ring for direct glucose measurement. So no, you cannot use this workflow to prove that a non-approved watch or ring meets FDA requirements. At best, you can compare its readings to same-day lab values and decide whether the agreement looks usable for your own private review. How to use this workflow on your own monitor without overclaiming. If you want the most useful result for your own device, use lab days strategically. On the morning of a fasting lab, capture at least 2 glucose readings the same day, enter those readings, then enter the lab fasting glucose value. Repeat that across multiple lab dates. The more matched dates you have, the less one lucky comparison can distort the picture. Then read both the overall summary and the individual lab rows. That combination gives you a practical consistency check without pretending you ran a clinical validation study. Bottom line for this sample accuracy report. So the bottom line for this sample file is clear. The direct glucose readings look very close to lab fasting glucose overall, and the SMBG snapshot shown by the app is inside the FDA-style limits displayed on screen. But the correct wording is important. This is a limited same-day snapshot using your recorded data, not a formal FDA accuracy determination, and it cannot certify non-approved watch or ring glucose devices. Used that way, the report is still very helpful because it turns scattered readings and lab dates into a repeatable, auditable personal accuracy check. About the app, privacy, and where to get it. Therapy Impact and Glucose Analyzer is by Werner Tools and Chris Werner. It is a Windows desktop application for personal tracking of blood pressure, glucose, weight, medications, and dated lab results. Privacy is straightforward because the workflow is built around local files on your computer, and the app does not upload your readings, reports, exports, or backups to cloud services. The full app can be obtained on Etsy for $9.95. Use the link shown on screen, etsy.com/listing/451-336-5729, or scan the QR code shown here.